Hey everyone, it's Miss Lloyd again, and we are coming up on one of my favorite things to talk about, asymptote holes. I know it sounds really weird, but basically we have our asymptotes, which is a line that we cannot cross because we're dividing by zero. An asymptote hole, or a discontinuity, is what it's technically supposed to be called, but I mean, which one's better? Leave a comment below. Tell me which one you think is better. Anyways, so this is where whenever we have our polynomial on top, polynomial on bottom, they're able to factor, and one of those factors ends up canceling out. So even though it cancels out of the function, it still affects the fact that we would have had a zero in that place to begin with. And so it creates this asymptote hole that isn't necessarily an entire asymptote line, it's just a little circle. So say we end up with a parabola, and we would have had an asymptote around this area here. So then it becomes just a little blip that we cannot touch, and then it just goes around it. So an asymptote hole. And so whenever we're graphing rational functions, this is a list of steps on how to do so. And so the first step is to simplify your function as much as possible. And so that means that we can try to factor things. We can see if we can cancel any factors. We want to try to just break it down as much as possible. And then we'll list any domain restrictions, including from the canceled factors. So from the canceled factors. So we want to see when we would have had zero in the denominator to begin with. We then want to find and plot the y-intercept by plugging in 0 for x. And then we want to find all of our zeros of the numerator. So setting the numerator equal to 0, and we'll plot those on the x-axis. So finding those intercepts, the x-intercepts and the y-intercepts, there's some pretty easy points, and they're one of the more important parts of the graph itself. So once we found the zeros of the denominator, that will tell us what our vertical asymptotes are, and so we'll sketch those vertical lines that we are not allowed to touch. They'll look something like this, and so that's when the denominator is equal to 0. We can find our horizontal asymptotes by doing that Bobo-Botten eats DC. So we're looking at the exponents of the numerator and the denominator. And then we'll find at least one point in between all of our important bits. So in between the intercepts, in between our asymptotes. So we just want to find like what's going on in between all of these important bits that we just found. And then we'll smooth out some curves in between all of those points. So then here, our very first graph. Again, the first step is to simplify. There's not really much to simplify since it doesn't have much of a numerator. So then the next thing that I want to do is figure out my y-intercept. So my y-intercept, I'm plugging in 0 for my x. So I'll have 1 over, instead of my x, I'm plugging in 0 plus 3. 0 plus 3 is just 3, so then my y-intercept is at 1/3. So then this is technically at the point 0, 1/3, because, you know, I plugged in 0 for my x and ended up with a third. So there's my y-intercept. I also want to figure out my x-intercepts. So here I can't actually set the numerator. The numerator is 1. I can't set that equal to 0. That's not really a thing. So there is no x-intercept. And then I want to find my vertical asymptote. So again, vertical asymptote, we're setting the denominator equal to 0. So we're not allowed to divide by 0. All of our tacos would explode because the world has exploded, and then we're ending up on Mars, and Mars is just dusty, and no one wants to live on Mars, and no one wants dusty tacos. I don't know how many times I said that, but it's a lot. So I know this is where my vertical asymptote is. So I'm going to have a vertical line, a line going up and down, where x is -3, and it's something that I cannot touch. And then I also need to find my horizontal asymptote. So my horizontal asymptote, I'm looking at the exponents. So here I have a 1 on the bottom, and I don't have any variables on top. We could say that's x to the 0 power. But really, we don't have to. There's nothing there. So then this is definitely bigger on the bottom. So that's our Bobo. So that means that we have a horizontal asymptote at y equal to 0. And that's what the O within a Bobo stands for. So then now that I have all these important bits, I want to plug it into a t-chart and figure out the stuff around it. Also, if you're a visual person, it may help to graph some of these things and see what you're missing. So I could say, okay, I had 0 and a third is my y-intercept. And then I had a vertical, asymptote at -3. And then a horizontal asymptote where y was equal to 0. And this is why we didn't have an x-intercept, because we ended up having an asymptote on the x-axis. So then we can't cross something that we're not allowed to touch. And so now I know I need to find some stuff that is over here to the right of my vertical asymptote, and I also want to find some stuff to the left of my vertical asymptote. So then I can plug in some of my fancy numbers. Since I went left and right of my asymptote, I'm going to put that there in the middle and a big ol' nope. Or you could be a little bit more specific and say, oh, this is the vertical asymptote. Thus, nope. Can't plug that in, everything will explode. So I want some things to the left, so maybe -4 and -5, and also some things to the right. So maybe -2, -1, and I already know what 0 is. That's the 1/3. So then now we just plug these into the original function. Once we've plugged all those numbers in and we now have all of their y values, we can graph them. So then here, if I'm reading left to right, I would be going through these points and down. And same with these, I would be going through and down for these points, which means I'm coming from above. Again, we're going along those asymptotes, but try really, really hard not to touch them. Last thing that we want to do is figure out what the domain is. So here it says state their domains. So here, my domain, my x values, the only thing I cannot plug in is at -3. So my domain is everything except for -3. So x is not equal to -3. And then we're finished. I'm saving that one for my babies. And so this is the next one that I'm going to go over on the YouTube. I think saying that makes me really old, but oh well. I'm almost 30. That's so sad. Okay, I'm probably going to look back at this when I'm 30 and then just like, I don't know, and be angry at myself. It's okay. All right, so first thing we want to do is try to reduce what we can. I see I have a quadratic in the bottom, so I'm going to try to factor that. So now that I have it factored, it doesn't look like I can actually cancel anything out, but it is really convenient, especially when I have to end up setting the denominator equal to 0 to find my vertical asymptotes anyway. Would have had to do it anyway. So now that I've done some simplifying, I'm going to find my y-intercept. Just plugging in 0 to all of my x's. And it looks like my y-intercept is at the origin. And that's okay. And also that means that my x-intercept is also going to be at the origin, since that is where the x and y axis meet. I can still show you how to plug it in though. So now that I have my intercepts, I'm now moving on to the asymptotes. So my vertical asymptote, we're setting those factors that were in the denominator equal to 0. And because these are multiplying and equal to 0, I can set each one equal to 0. And it looks like I have 2 asymptotes. And so something interesting when it comes to vertical asymptotes, if we have 2, then our horizontal asymptote technically doesn't go in between them. And we have full reign to cross our vertical asymptote in between these two, the horizontal asymptote in between the vertical ones. The last thing I want to find is my horizontal asymptote. So horizontal asymptotes, we're looking at the exponents. I have a 2 and a 1. This is bigger on the bottom. Because I've got the bobo, that means my horizontal asymptote is going to be equal to 0. So I have my horizontal asymptote. I'm going to graph my 2 vertical asymptotes. So now that I have all of my asymptotes written down, I want to now find all the stuff that happens in between. So now I have 3 sections, to the left of the first one, in the middle, and to the right, that I want to figure out all the stuff for. So in my t-chart, I'm going to put all of those things. Now I know I've plugged quite a few things in here, but we can use our calculators to plug in each of these values and find our y values. Now that I have all my values, I'm going to plot them on my graph. And so here we can see how the function is kind of breaking that rule of the horizontal asymptote. So it can break the rule when it's in between two vertical asymptotes. So there's actually, if you watch Pirates of the Caribbean, there's Barbossa, and he always says, the rules are more like guidelines. That's how the horizontal asymptotes are, in my opinion. And then we have our massive mess of this function. The last thing we want to do is do our domain, which is really just our vertical asymptotes, and saying that we can't have those. And that's as far as I'm going to go on YouTube. I'm going to save the rest for my kiddos. I hope you guys have a great rest of your day. If this was helpful, please like and subscribe. And if you think someone else might get some help from it, then please feel free to share. Sharing is caring. Spread the love.